Okay, so let's get started. Let's do a little bit of coding and practice what we just discussed. Let me show you the example that we are going to build together. What I have prepared for you is the basis of a program which I call Monster Builder. Essentially, it's very similar to the figure builder that I gave you, I think it was in one exam. What we are essentially going to do, we are going to use this Monster Builder pack. It's an open source image library with some eyes, as you can see them here, and some bodies, and some legs, and some arms, and some noses, and so on. And with these components, you can build monsters like that, okay? So what we essentially are going to do is we are going to build a web API where a user can, for instance, choose which legs do I want to have, which arms do I want to have, which mouth do I want to have, which eye do I want to have, and which color do I want to have, and then we are going to build a monster image for the user. Let me quickly demonstrate how this looks like. I will run the sample. It's not completed. You have to complete it on your own, but I think you will get the point from the basis that I created. If I go here and show you the requests, then we see the state. See, the first one is, for instance, this build image URL, where we can say I want a monster which has the color red. The body should be F. Let me show you that, how that looks like. If I scroll down, you see various bodies. You see A, B, C, D, E. And if I take a look at F, you see that this is this shape with a bunch of whatever these things are. E would look like that, D would look like that, C would look like that, B would look, I think you get the idea, right? So we can choose whichever body we want from our monster. We were here. Then we can choose the body type, the body color, and the legs. The rest will be up to you to implement. So if I send a request here, what I will get back is a URL. And inside of this URL, here we have state, you see? So what we essentially encode here is a URL where we save in an encrypted fashion the settings of our monster. And we round trip that state. So this state is not stored on the server side, but it is sent back to the client in the HTTP response payload. And I also use a header, the location header, as you can see it here. And next, I can use this URL, I can click on it to get the image. And you see, it's not completed. You only see 2 legs and the body. So our monster doesn't have eyes and a nose and a mouth and maybe some horns and arms. That will be up to you to complete it, okay? But I think you got the idea, right? We round trip the state. But we cannot tamper with the state. So if I copy this thing, this one, and I copy it here, and for whatever reason I change one letter here. Oh, that was not a good demo. Maybe I have to change more than just one letter. Yeah, exactly. It doesn't work. See, cryptographic exception. Doesn't work. Of course, in a real-world application, we would handle that exception, but in our demo, it's perfectly fine if the program crashes. It's okay, but it's protected. So we encrypt the data that we transfer to the client. We round trip the state. This is what we are going to build today. And we are going to build that together, step by step. And at one point, I will tell you, hey, complete it on your own. Okay? So let's get started. I invite you to follow along. You can create a new app. I will do it, I don't know, somewhere here. I will call it Monster Builder. Monster Builder, and do a .NET new web. We did that in the last few sessions, and then you can open it up in Visual Studio Code. Here it is. Well, the first thing that we have to do is kind of boring, but we have to do it. You have to get the images, right? And of course, I prepared these images for you. They are in our course repository. Please clone the course repository or update it. So do a git pull on our course repository. And there you will find examples Monster Builder, and once you cloned it, please copy the entire images folder into your application. What I can do for you is I can, give me a second. Examples, Monster Builder, images, Explorer, something like this. To make your life a little bit easier, I can take all these images here and put them into a zip file and copy this zip file on Discord. So if that's easier for you, that's perfectly fine. I'll call that monster parts here, and I will copy it to Discord. Give me a sec. So now you have the monster parts zip file also in your Discord. What I'm going to do, so you know what you should do, is I'm going to simply take this images folder and copy it here into my application. See? Now I have all the images here in this folder, and this is exactly what you need. I will give you 2 or 3 minutes in order to download either the zip file or the GitHub repository, create the images folder, and put all the different images inside of this folder. Please do so. Very nice. So everybody has this images folder. And the last thing that we need to do in order to make this images folder available for you, I see some of you are using the live share link, that is fine. In order to make this images folder available to us, we are going to change the CSproj file a little bit. What we can do is we can make this images folder here so that it is deployed together with our application when we publish the app. So if we want to publish this app and put them on a cloud web server or the Leo cloud, for instance, then we can tell SkiaSharp that it should take all the images and copy it with us. Let's quickly complete that, and then we'll do the break, okay? So what are we going to do? Here in our project file, please add another item group. This is how we do that. Item group. Inside of the item group, we create something which is a kind of strange. Include, non-include images / star. This is how we do it in CSproj. You can copy it whenever you need that. And then we are going to say copy to output, no suggestions, directory, something like this, preserve newest copy to output directory. So if you don't want to type that in, feel free to do so, but this essentially tells SkiaSharp, hey, take all the files from the images folder and copy them into the output directory. Let me show you what the result is. If we say .NET build, and if I take a look at the bin folder, debug, net5, see, in the resulting folder, which was built from our source code, all the images have been copied into the target folder. So whenever we publish our app, we also publish the images. Do you understand what I mean? Yeah? If you can't remember this code snippet, maybe in your future projects, use Google or ChatGPT in order to ask it what you have to enter in the CSproj file, or use this project as a template, okay? Exactly. Does that work for everybody? Good. So let's do a 5-minute break, and after the break we are going to start to implement the API that builds our monster images. So welcome back from the break. In the last minutes before the break, we added the images folder, and now you should have all the images in this folder here. And just for your reference, to make it easier for you to build monsters, in the GitHub repository, I have added an overview picture, as you can see it here, over all the different parts with all the different names. So I will just copy this URL into the Discord server, so you have a kind of reference that makes it easier for you to build monsters. So now you have the link in your Discord server. And we can start coding. Go into program.cs, please. And here we are going to start writing code. Let's start by building the first URL endpoint. In the first URL endpoint, just to refresh your memory, we will send the image options, which is just a record consisting of the body type, the leg type, the arm type, the eye type, the color, and so on. So the first thing that we need some kind of data transfer object to store our image options. Let's do that. At the very end of our program CS, let's create a record, call it image options, and I would suggest for now, let's say this is string color, this is a character body. Why do I use a character body? Ah, very nice. So you're back from your presentation.
Yes.
Let me quickly complete this thought and then we will take you on board, okay?
Thanks.
Yeah, you can close the window now. It's perfectly fine. Just we had it open for a second. And character leg. Why do I use a character? Take a look at the images. You will see that here we always have the color. See it here? And after the color, we have the type, which is A, B, C, D, E, F, or something like this. You can look it up yourself. So this is essentially our data transfer object in order to store the image options. Okay? And now we will get you on track so you can also join. Okay? Give me a second. I will just put everything together in a zip file and send it to you via Discord, and then you can simply unzip it and you are exactly where we are. Okay? Give me a second, I will do that. Very good. So now you are up to speed, so we can continue building our nice little API. So again, this image option here will be the payload of the first request. Let me quickly draw a little bit so you know what I'm talking about. So we have the client here on the left-hand side, and we have the server here on the right-hand side. I drew a similar picture on the digital whiteboards in the first hour, but let's now relate this picture to what we do now. The first request will be image options going in. Which color do I want the monster to be of? Which body should it have? Which legs should it have? And the response here will be an image ID. Essentially, it's the whole data that is necessary to build the image later on. It's the state that we are talking about. And later on, the next request here will be a get image. And it will send in the image ID. This image ID will then be decoded by the server. The server will generate the image and it will return the generated image to the client. Got it? So the state that we have here is exactly that image ID. And we will talk about this image ID in great details later on. Yeah, question?
Is there a reason why we not just send the generated image back at the first request?
Yes, because I would like to show you how stateful web APIs work.
Okay.
The second thing is the image options are posted from the client to the server.
Mm-hmm.
It's very hard for a browser, for a web browser, to display an image based on a post request. If you use an image tag in HTML, you cannot specify that this image should be read from the server by doing a post request. You can only do a get request. With a get request, you cannot send a body. Understand what I mean?
Yeah, sure.
So if I would like to send the image options in a JSON format to the server, I need a post request. So I split it up. And this is exactly where state management comes in. I send the image options in the first request. And in this case, if you watch the recording of the first hour, you will understand what I mean. In this case, I decided to not store the image options in some kind of database. I could do that. I could store it in a database and return just the primary key, some GUID or some number. And later on, the user can reference the ID and I read the image options from the database. But I don't want to do that. I would like to round trip the data. So I store all the necessary image options here in the response and let me send the image ID again. So we round trip the state. Got it? Good, very good. Nice. So this is the image options here. Now we can build the API with which we can build the image URL. And for that, we are going to go here and delete this app.mapget with the hello world. We don't need it. We want to build an app.mapPost. I hope you can remember post, yeah, for creating things. Yeah. Let's call it build image URL, something like this. And here we take the image options. Let's call it options. I forgot this one. And this is where we are going to write our code. Do you get the idea? This post request receives the image options, the color, the body, the leg, the hands, the eye, the nose, the mouth, whatever. And now it has to build this ID. And we want to encode the whole image options thing into this single ID. And we also want to protect these image options. We want to encrypt them so that the client cannot tamper with it. Imagine in the real world, this could contain some secret passwords or credit data information or whatever. So we want to encrypt this stuff. We're going to talk about how encryption works with ASP.NET Core. Did you do some exercises in other courses about encryption? Symmetric encryption, asymmetric encryption, things like that? Was it complicated? Little bit. In ASP.NET, it's trivially easy. You will see encrypting and decrypting stuff is so simple if you do it in the right way. So don't worry. It will be rather simple. Good. First, we need to somehow build a string from our image options. One possibility would be to build a JSON string. We could do that. But this is rather long. It's rather bulky. Let's write our own little string encoder if you want. Just follow along. You will immediately understand what I'm going to do. It's just a demo, okay? We will add to the image options. You see, I just added the curly braces here, so I can add functions. Public string, let's call it toShortString. And there we are simply going to concatenate the color, the body, and the leg and separate them with a dash. We are not going to add some error handling here, so that's fine for now. And of course, we also have to do it in the other way around. We say public static image options. Let's call it parse. That's a good idea. String value, and I think... No, it's too complicated. GitHub Copilot is... that is good. I accept that suggestion. Oh, I forgot the C here in public. I'm sorry about that. And what else did I forget? Static image options.
The arrow to remove it.
Yeah, sorry. We don't have a lambda. Now it works. Sorry for my typos. See, it splits up the string. So it splits it up into 3 different areas. The first one will be the color. This one. The second one will be the body. See, here. And the third one here will be the leg. Got it? Here? Good. So now we have a very simple option to convert everything into a simple string, not as bulky as JSON, very short, and we can parse everything back. That is good. We can do that. Yeah, question?
Shouldn't we then only include one dash in the toShort string if we only split it with one?
Oh, this split returns an array. So if you use split, what you get back is an array with 3 elements. The first element is color, the second element is body, and the third is leg. So by specifying the dash, we automatically get an array of strings, and we can get back the things. Understand what I mean?
Yeah, but we have 2 dashes at per
Yeah.
the string. Does it still work?
Yes, absolutely. by saying split dash, it will split our string and give us, whenever it finds a dash, it will return this one, it will return this one, and it will return this one.
Yeah, no, I'm just blind. I thought we had 2 dashes.
No, it's just one. It's just one. Yeah, that was just, then it was just a misunderstanding. It's just one. Just one. Okay. Good. Good. Let's give it a try. Let's take the image options and convert the image options into an option string. Var options string equals options dot to short string. Okay, good. Then let's build the response URL, var URL equals to, and I'm going to make it first not beautiful, and then we make it more beautiful. HTTP localhost, oh, I have no idea which port. I will say 5000, but this is obviously wrong. The images will be available under /img, and afterwards we are simply going to use options string. Okay, something like this. This is ugly, and we have to get rid of this one. I will show you that in a second. And now comes the important part. First, we simply do, we try the simplest things first. Result.ok, and we are going to return new object, something like this, and we will say the URL equals to exactly that URL. Okay? Understand what I do? I simply take the option string and I return it as a kind of URL. If you can't completely understand what we are doing now, let's try it and then it will become clearer. Please run the application. You can either run it by pressing F5, running it in the debugger, or you can say .NET run, whatever you prefer. I use the debugger here. I am going to use the REST client. We practiced the REST client already. You can also use Postman if you like, okay? Request.http, something like this. And then we simply say post. Now, what is the URL that we have? I have the port 5285. So this is what we have. Build image URL. The content type is JSON. And here, what did we have? We had the color, right? I will start with green. We had the body. I will start with body F. And I think we had the legs, right? Or leg. I have to check it. I have to check it. How did I call it? Leg. Singular, not plural. Leg will be, what am I going to use? I'm going to use C. Leg C. Now once you have that, and if you run this, you will get back exactly this URL. See? So it says, hey, if you want to have this image, just call this URL, and see here we have this green-f-c. And this is what I mean with state. We built the state on the server and sent it back to the client and told the client, if you want a monster like that, you have to use exactly that URL. Got it? That's the idea. But you see, this is now wrong. It's not localhost 5000. It's localhost 5285. So now we have two possibilities. We can either go to the program and fix it manually, here, 5800, I don't know what it was, but this is not very beautiful. So let me teach you something new. And this is now new content. Okay? What we can ask ASP.NET Core for is the so-called HTTP context. Let's call it context. The HTTP context is very, very powerful. It gives us access to all the different parts of the request and the response. By the way, when I have that, I will put everything in a zip file and send it to you so you can also join it. Just regulate. Just let me finish this thought and then we'll bring you on speed, okay? Good. So the HTTP context gives us access to all the data of the request and all the data of the response. It's a kind of low-level access to whatever we got in and whatever we sent back. So what we can now do is we can here, instead of hard coding the local host whatever, we can simply say use the server that we got in the request. So we can say context.request.host. And then it will always be correct. If the port changes, it will always be correct because we simply say we take the same host that we are on. Understood what I mean? Now it could also happen that for production use cases we use an SSL certificate, HTTPS. So we have to make this one dynamic too. No problem. There is another context.request field and this is called the scheme. The scheme will be either HTTP or HTTPS. And with that we have a beautiful solution because we can now move our code between servers and the response will always be correct. Do you understand what I mean? Nice, let's give it a try. Let's run this thing. Use Postman or the REST client. And if you try it, it should now be correct. See? Here, this is now automatically identical. This is what we did by using the HTTP context. So if I ask you in the future, give me a sec. If I ask you in the future, how do you access the raw elements of the request and the response, your answer should be through HTTP context. Got it? Let me finish this thought and then I'll answer your question. We can also access the response like that. We can, for instance, say, let's write another line of code, context.response.headers.location equals to URL. So we can set headers that we send back. We can set cookies if we want. Through the HTTP context, we can access the raw elements of the request and the response and many additional things which we are not going to talk about today. So if I try that one, you will see that on this one, that we now have a location header, you see? Works perfectly fine. Exactly like I wanted to work. Now you have a question.
Yeah, I didn't get what exactly the context is.
The context, it's just a means of accessing the request and the response. Normally, we don't need to access the request and the response because the request will be automatically parsed for us, for instance here. But sometimes we want to dive deeper. We want to know the host and the schema and many other things. So if you need to drill down deeper compared to what you get out of the box, you need the context. Or if you want not just to return some JSON, but you want to manipulate the headers or things like that,
yeah, sure.
Then you get the HTTP context. It's optional. You don't need to ask for the context, but you can if you want. And this is exactly what you should remember from this example. Low-level access to request response, HTTP context. Got it? Okay, very good. Now I ask you again to quickly open the window, just for a short amount of time to get a little bit of air. Yeah. Very good, just for a minute or so. Good. Got it? Now I promised you, because you were a little bit late, to invite you to join us. So give me a second. I will put everything in a zip file, put it again on Discord, and you can grab it from there. And then you will be exactly where we all are. Give me a second. Okay, so we learned about the HTTP context. We have to learn something new, something additionally new. Because, let's be honest, if we take a look at this request response, here, the data is sent back to the client in plain text. That might be okay for our monster builder. But in many applications, we want, as a server, we want to keep secrets from the client. We want the client not to be able to change the state. So we need to encrypt the state. And this is exactly the next thing that I would like to show you, how to do that in ASP.NET Core. And it's really, really simple. Please follow along. At the very beginning, where we have this builder thing here, we already talked about this, I think, in the first week. If not, no problem. Just follow along. You will immediately understand it. We can add data protection services to our app. So we simply say builder.services.add data protection. It's as simple as that. ASP.NET Core has data protection built in. Of course, there are a lot of configuration options. You could do so many detailed configuration if you build professional software, but for now it's perfectly fine to simply say add data protection. For simple scenarios, that's okay. And that's all we need. Now if we want to encrypt something, we simply, in our handler function, ask for something which is called an iData protection provider. iData protection provider, and then use the light bulb in order to add the using statement. See, this is what you need. This is the using statement. So please add the iData provider. Data protection provider, sorry. And this thing will be responsible for encrypting our thing. Encrypting a string in ASP.NET Core is really a very simple three-step process. First, we need to convert the string into bytes. That is very simple. We simply say var options bytes equals to encoding UTF-8 encoding, come on, encoding, we need the light bulb using system text, UTF-8 get bytes, option string. Are you familiar with UTF-8? Yes, no, maybe? Maybe? You know what ASCII is, right? American Standard Code for Information Interchange. You know what Unicode is, right? UTF-8 is a combination of both. It's ASCII for simple characters and multi-bytes for emojis and stuff. Okay, so it simply gives us, in our case, because we only have simple characters, it simply gives us the ASCII codes of the characters. You can close the window if you want. So this is what we do here. If you need that in your exam or homework, you simply copy it from my slide here, or ask ChatGPT, or you go to StackBlitz, whatever you want. It's really simple. Next, we need to ask the protection provider to give us a so-called protector. var protector. We say provider.createProtector, and inside of this createProtector, we need to describe what we are going to do with this. You can write anything here. I can write Hansi here if I want. It really doesn't matter. It's just an identifier. It's just an identifier. Next, we encrypt the data. And this looks like that. That's all we have to do. That's super professional grade encryption. Configuration is not so great what we did here. It's just for a sample. But that is a nice thing with ASP.NET Core data protection. Encrypting something is really a piece of cake. If you think back how difficult encryption would be if we use low-level building blocks, but this is trivial. Ask for a protection provider, generate the protector, and call the protect method. That's all. Guess how complicated decryption will be. We are not going to call protect. What do you think are we going to call? Unprotect. And that's encryption. It's really as simple as that. I really like that. I think it's super important that Microsoft makes encryption and decryption in ASP.NET really simple. Because by making it simple, developers are using it. If it's too complicated, nobody is doing encryption. Or people are doing encryption wrong. Okay, now we have the encrypted bytes. And last but not least, we need to convert that into something that we can transfer to the user. Next question. Are you familiar with base 64 encoding? What is base 64 encoding? It's a tricky question, right? Yes, we could ask ChatGPT, but we don't want to ask ChatGPT everything. So what is base 64 encoding? With base 64, you can essentially take any kind of data, any amount of bytes, and transform it into a string which is readable and typable by humans. So it's a string representation of bytes. If you have an image and you would like to store that in a text file, base 64 encoded. If you have a music piece and you would like to transfer it in the URL or whatever, well, not in the URL, but in the response, request, whatever, base 64 encoded. Whenever you have a byte array and you need to transfer it into a readable string, base 64 encoded. There are super nice tools on the internet. Just Google for, I don't know, base 64 encoder, something like this, and you will, for instance, find this website where you can type in anything, whatever you want, and then you simply press, sorry, I want to encode, so I go to encode here, type anything here, press encode, and what you get back is the base 60, sorry, encode, come on. Yeah, here it is. And here you see the base 64 stuff. See? It's not encrypted, don't get me wrong. This is just encoded. So whoever wants this thing to have can go here, can go back to decode, paste in this thing, do a decode, and the user will get the plain text again. It's not encryption. Base 64 is turning a byte array into a string. And this is exactly the last thing that we have to do. We have to transfer our protected bytes, which are just any kinds of bytes, into a base 64 string. And that looks like that. Protected string, web encoders, this is how you do it. Encoders, we need the light bulb again. Dot base 64 URL encode, this is what we do because we want to transfer it through the URL, and then it's good. See? And this is what we are going to give back. Protected string. See? Now we are no longer returning the original string, but now we return the encrypted string. Give it a try. Run it. Run it. Try the request, and you see this is now professionally encrypted stuff. The client has no way of understanding what our state is. But we as the server, we can decrypt this stuff. Got it? So let's quickly summarize what we did here. Zoom in. The first thing that we did here is transfer our data into bytes. They're here and here. This is what we did. Then we ask for the protector and call protect. This is the encryption stuff. the result is some kind of bytes which cannot be displayed in a URL. It needs to be printable characters. So therefore, we use base 64 URL encoding to get a string. And then we are good. Got it? Understood? So whenever you round trip data and you want to keep this data secure, this is a nice way of doing it. It's just 5 lines of code and you are secure. Of course, you don't need to remember this thing. You can always go back to this example and copy it from here, or use ChatGPT or Google or Stack Overflow or whatever you prefer. Are we good? Nice. And just before the break, let's try the decryption part. Okay? So let's do an app.mapget, and it will be rather simple. img image ID string image ID, something like this. And again, the the data protection provider. And just to give it a try, we are simply going to decrypt our data and return it, just to make sure that we can really decrypt everything properly. We need the protector first. First, we need to undo it in exactly the opposite direction. First, we don't do the base 64 URL encode, but what do you think is the reverse operation for encoding? Decoding, right? So let's just copy this this line here, move it down, and this is now here the image ID, and we don't URL encode, but we URL decode, and the result will be the protected bytes. So we turn the string into bytes again. Then we need the protector. We can copy this line up here, the protector. And then we can not protect, but unprotect the protected bytes. And that will give us the options bytes. You see, we are performing exactly the operation in the other way around. Next, we had this UTF-8 get bytes. So we will again do exactly what we had before, but this time we don't say get bytes, but we say get string. And we pass in the option bytes. And this will be our options string. And last but not least, we get the options by parsing this string. Hooray! We did it! That's it. That's exactly what we wanted to do. So we perform exactly the same steps. Decode, unprotect, get string, parse, in the other way, in the other direction. In the other way around. And just to try it, we are going to say return results OK options. Just to try it. It doesn't make sense to return it. We want to build an image here, but this is what we are going to do in the third lesson. Okay? Let's give it a try. Let's run it here. Let's run this post request. This will give us a URL, and if I follow this URL, you see, it's correctly decoded. It works fine. So we decrypted it, we decoded it in exactly the way that we like. So I will mark it here. This is the encode, encrypt stuff. And this one is the decode, decrypt part. These code snippets are relevant. They will be maybe relevant for an exam. They might be relevant for a homework. So please remember what we did here. Is it complicated? No, it isn't. I'm absolutely sure it is not. You simply have to understand what encoding and decoding, encrypting and decrypting means, and then it's super simple by using the ASP.NET Data Protection API to encrypt stuff. So please finish this code. If you have any problems, let me know. And with that, after the break, we can start building the image. Okay, so welcome back after the break. We encrypted stuff, we encoded stuff, and now it's time to do a little bit of image building, right? And for building the images, we are going to use a rendering engine. Oops, sorry. Here. We are going to use a rendering engine which is called Skia. Have I ever heard about Skia? Did I tell you about Skia already? No, never heard about Skia. Skia is one of the best and fastest 2D rendering engines that you can currently get. You use it on a daily basis and endless amounts of time. It's the rendering engine that is built into Chrome. So if you use Edge or Chrome, you always use Skia to generate the images. Skia is painting the pixels on the screen. This is what Skia does. Now, Skia is implemented, I think, in C or C++, and it has a lot of bindings to other languages. And we are going to use SkiaSharp, the SkiaSharp version, which is a very nice wrapper in C# with which we can build images. So whenever you need to build images nowadays, it's a good idea to at least think about Skia. So let's add Skia to our application. In order to do that, we are going to add two dependencies here, and I will copy this from my prepared sample, and I'm going to copy these two lines immediately into Discord, so you do not need to write them down by hand. So now you have these two dependencies in your Discord server. As you can see, we reference SkiaSharp, which is the .NET library, the .NET wrapper around Skia. And I know that some of you are using Linux distributions on your laptops. So I added a second dependency, which is called native assets Linux no dependencies. That means that Skia should immediately work in C# on your Linux distro without you having to install any kinds of prerequisites. So if you're working on, for instance, Ubuntu or something like this, I think you could even skip this one. But let's keep it in just to make sure then we have no dependencies. Good? Good about that? Good. Nice. Now that we have Skia, we can start with coding our drawing stuff. Okay? Good. Nice. Let's go here. In the map get here, the first thing that we are going to do is we are going to create a so-called surface. The surface is the drawing surface on which we can draw rectangles and lines and circles and images. This is the first thing that we are going to do. We are going to say var surface equals to sk surface. SK stands for Skia. You need to use the light bulb in order to get the Skia namespace. .create, and here we can pass in various options. The easiest thing to set everything up is to say new SK image info, and there we can specify the width and the height. And I'm going to use 500 pixels. So we are just creating an empty drawing canvas. Canvas in German means Leinwand, the drawing canvas, where we can paint 500 by 500 pixels. Are we good? Now, once we have a surface, we can generate the canvas or get the canvas by asking this surface for .canvas. And the last thing that we are going to do is we are going to say canvas.clear sk colors.transparent. If you would like to have a different background color, red, blue, green, whatever, use a different color. Here you can specify all the different colors that you want. But in our case, we simply say we have a transparent background. Okay? So the monster is standing in front of a transparent background. Does it make sense? Whenever you want to draw something, just remember or copy these few lines of code. And now we are ready to draw. Let's make sure that we know how to do the very basic drawing options. And it's really simple to take our images and draw them on the screen. The thing is, we cannot draw an image directly by using its file name. First, we have to read all these images into memory, and then we can draw them onto the canvas. We good? Okay. For that, we need to, again, read this image and put it into something which is called a Skia bitmap. Let me show you how we do that. Can you remember in the options we have these things like color, body and lag? Now if we take a look at the images, we will find something which is called here, for instance, body blue E. Now this blue is the color, obviously. This E is the body type, and this body underscore is just a constant. You got that so far, right? Good. So let's read the corresponding file into memory. For that, we are going to say file.openRead, and then we need to build the image file name. For that, we say path.combine images, that is the folder, and inside of the images, we now need to build the file name. It consists of body underscore, then we are going to say options.color, oh, it has an uppercase C, sorry, and then we are going to say options.body, and at the end it says .png. Do you understand what I do here? I'm building the name of the file by concatenating body underscore, then the color, and then the body. And that should give us something like body underscore blue A .png. Good? Yep. Nice. Now we can ask Skia to read exactly that, that file. The thing is, we have to store that in a stream, var image stream. And then we can say, what are we going to say? Var body equals to exactly, GitHub Copilot suggests exactly the correct thing, sk bitmap, which is a Skia bitmap.decode image stream, and that's it. It's as easy as that to load an image file into Skia. Complicated? No. And finally, we draw this bitmap on our canvas. That's the last line here, and then we can immediately convert that into a PNG file and send it back. Canvas.draw bitmap, body, and then we can specify the location, 0, 0, for instance. Yeah. Just on the lower left, on the left top corner, we say draw the body. So these are the steps that you need to do in order to start drawing. Create a canvas, set the background, read the image file, call draw bitmap. Last but not least, we need to convert that into a real image. That's also just 2 lines of code. Var result image equals to surface.snapshot. Var image data result image dot encode and that is exactly what I want to have. Yep. That encode here gives us the PNG and the quality. If you want to have a smaller image file, specify a smaller number, something like 75. If you want to have the best possible quality, 100. Choose yourself. And that's it. That's all we need to do. We can immediately return that as a file. Let's take the image data.toArray. That gives us the array of bytes and tell it that it is a PNG file. Done. It's as easy as that. Isn't that beautiful? Create the canvas, set the background color, draw something, make a snapshot, encode it as a PNG, and you're done. This is why I like Skia. It works on any machine, macOS, Windows, Linux, and it's super fast. It's not difficult. So if you do your final year projects, or if you do your 2-year projects, and you need to somehow generate some images, consider that. It works perfectly fine. Even if you use other languages, if you use Rust, if you use Go, if you use Node.js, there are wrappers for Skia for all of these languages. It's very widely used. Good. Let's give it a try. Let's run our app. Let's go back to the request HTTP and generate the URL. If I run this request, we get the URL. See that one? I can now take this URL, or I can just click on it, and it will open up in the browser, hopefully, in the browser, and woohoo! We have a monster, at least a monster body. It is green. It is the correct type. Awesome. Let's try to change it to red. You get the idea? Run it again. You get a different URL. Call the URL, and we have a red monster body. So, it works perfectly fine. Please try it and tell me whether it works. It's not difficult, is it? If you know the APIs, and now you have a template that you can use for future projects, it's really not that complicated. Does it work on the Linux machines too? Yeah? Awesome. Perfect. Now we have the body. Let's maybe move the body to a different position. Let me show you what I mean. What we can do in order to position the body, where is it? Here, with the draw bitmap, we have two options. On the one hand side, we can change the position of the body here. I could, for instance, say, put it on the location 150 and 50, something like this. I could do that. But there is a better option, which I ask you to do. You can do the following thing. You can say, here, canvas.save. Please just follow me and trust me that it makes sense. And after the draw bitmap, you say canvas.restore. And in the middle, you can say canvas.translate. Translate in English does not only mean übersetzen in German. It also means verschieben in German. Move, translate, okay? And in the translate call, you can say where you want to translate it to. Please try 150-50. If you try that one now, you will see that our body here is on a different position. Hopefully. No. It crashed. Why did it crash? What did I do wrong? Let me try again. Oh. Failed to bind to... Oh! The program is still running. Why is the program still running? I forgot to stop it. So I ran it twice, and that's not a good idea. So hopefully it works. No, the program is still running. Okay, I have to restart Visual Studio Code. I'm very sorry about that. Shouldn't be a big problem. So this is my monster builder. Something crashed. I have no idea what. No problem. The ultimate the ultimate solution in programming is restart, isn't it? Okay, I have no idea why. The port is in use.
Maybe kill it in the task manager.
Maybe kill it in the task manager. Let's give it a try. Here. And it should be... .NET, let me take a look here in the details view. I'll do something else. This is just my problem. I hope you don't have the same problem. I can tell you a secret. Here in the launch settings file, you can choose the port. You see it here. And I'm just going to use a different port here, 5286, not 85. Come on. Oh yes, it now works. Whatever happens, it doesn't matter. So let me try the request. Run it. Run it. And our monster is still on the same position. So what's going on? Finally, it was still the wrong port, but now we have the correct port. You see, now we have a translation in the X and Y coordinate direction. And the reason why I did that with the translation is that we can do much more than just translate it. We can, for instance, also do something like canvas dot rotate degrees. Let's rotate that by 45 degrees. Do you get the idea? So that works perfectly fine. Imagine that you want to have a leg and you don't want to be the leg just hanging down, but you want to put the leg somewhere else. You can easily do that. Let me show you that. Now I rotated the body, and that gives me a monster with a 45-degree rotation. Very good? Makes sense, right? No, it doesn't make sense to rotate the body. I fully understand, but I think you get the idea. I'm just showing you a bunch of Skia tricks. So with that, we can easily translate and draw a bitmap. And that is exactly what I wanted to show you. Now we have state management. Now we have the possibility to generate an image based on state that was round-tripped. Now you have Skia in your application to generate the images, and now it's up to you. That is your job for the rest of the hour and your job for the homework. Because I want you to finish this monster builder. So obviously you have to enrich the image options down here, because I also want eyes, I want arms, I want legs, things like, we have legs, noses, a mouth. So at the end of the day, what I want from you is a monster that looks somewhat like some of those. Okay? And I would like to configure it using the request. Got it? So it's your job to finish this monster builder. I hope that's a little bit of fun. The whole job is, the whole reason why I ask you to do that is that now you have to really consciously change the code. And by changing the code, you can revisit the concepts that we practiced in this hour. Do you like the monsters? I hope you like the monsters. Yeah. Did I already send you the link to this monster pack in Discord? So I sent you the link to the monster builder pack so you have a little bit of inspiration how your monsters could look like. So have fun practicing, try that, and let me know if you have any questions if something doesn't work. And remember what we did today with encryption, decryption, encoding, decoding, state management, and 2D image generation. So have fun.